Welcome to our video that will show you how to set up and carry out the GCSE Chemistry required practical on rates of reaction. There's actually two required practicals on the rates of reaction topic, and in this video we're going to be showing you how changes in turbidity can be used to measure the rate of reaction. We're going to be using the reaction between sodium thiosulfate and hydrochloric acid. To carry out this required practical, you need a stopwatch, safety glasses, conical flask, 2 measuring cylinders, a piece of white paper with a large cross on it, and the chemicals we're going to be using are sodium thiosulfate and hydrochloric acid. And when these react together, one of the products is sulfur dioxide gas, and to stop that gas building up too much in the air, we're going to pour any chemicals when we've used them into this stop bath, and that will stop the reaction. And there's instructions on the website of how to make up this stop bath. The first thing you must point out to your students is throughout the whole experiment, they need to be wearing their safety glasses. In this practical, we're going to be looking at how the concentration of reactants affects the rate of reaction. We're going to be varying the concentration of the sodium thiosulfate solution whilst keeping the concentration of the hydrochloric acid the same. We're going to be measuring how long it takes for the reaction mixture to turn cloudy. So it's important we have the white paper with the cross on, and we're going to stand the conical flask on top of that cross. The first time I carry out the reaction, I'm going to measure out 10 centimeters cubed of the sodium thiosulfate and add that to the flask. And then I'm going to add to it 40 centimeters cubed of water. This is just water in the beaker, and that's going to dilute the sodium thiosulfate. So each time I'm making up a sodium thiosulfate solution with a volume of 50 centimeters cubed in total. So I'll add the water to the sodium thiosulfate and make sure I give it a quick swirl in the flask. I'm now going to measure out 50 centimeters cubed of hydrochloric acid using a different measuring cylinder to the one that I used for the sodium thiosulfate. That's because there's still remnants of sodium thiosulfate in that measuring cylinder, so if we measured out the hydrochloric acid, the reaction is going to start before we want it to. So it's really important you stress to your students to use a separate measuring cylinder and make sure they know which one is for the hydrochloric acid and which one is for the sodium thiosulfate. So here we go with the 50 centimeters cubed of the hydrochloric acid. And when we add that to the flask, we start the stopwatch straight away and give it a swirl. And what we're looking for is how long it takes for the solution to go so cloudy that we can't see the cross through the solution. Now it's very important you tell your students not to have the nose over the conical flask, because otherwise they will be inhaling those harmful sulfur dioxide fumes. So we're going to come back to this in a few seconds when it's started changing turbidity. We've just got to the point where I can no longer see the cross on the white paper, so I'm going to stop the stopwatch, and now I must remember to tip out the chemicals into the stop bath so that we stop any more of that sulfur dioxide getting into the air. Because we want to change the concentration of the sodium thiosulfate solution, this time I'm going to add 20 centimeters cubed of the sodium thiosulfate, add it to the flask, and then I'm going to add 30 centimeters cubed of water. So I'm still making a total volume of 50 centimeters cubed. And then give it a swirl to make sure it mixes. And once again, I would add to it the 50 centimeters cubed of hydrochloric acid that I've measured out in the separate measuring cylinder. Give it a swirl, start the stopwatch, and see how long it takes to turn cloudy. As we repeat this, we've already done 10 of sodium thiosulfate and 40 water, and 20 sodium thiosulfate and 30 water. We would then do 30 of sodium thiosulfate and 20 of water, 40 of sodium thiosulfate and 10 of water, and then the last one, just 50 centimeters cubed of sodium thiosulfate. Each time we would be adding to it 50 centimetres cubed of hydrochloric acid undiluted. When the students have carried out all 5 results, they then repeat the whole process 2 more times so that for each concentration of sodium thiosulfate, they've got a set of 3 results, and they can use those 3 results to calculate a mean. Once they've worked out those means, they would then plot the results on the graph, and the graph would look something like this. Along the bottom, we have the volume of sodium thiosulfate because that's the independent variable that they have changed. Up the side, we would have the time taken to go cloudy in seconds because that's the dependent variable. It's important your students also know the control variables are the volume and concentration of the hydrochloric acid and also the temperature of the reactants. It's also important to let your students know that the main error in this investigation is when you decide the exact moment when the cross is no longer visible through the solution. Now that's a good example of a random error because sometimes the times may be a second or 2 too long, sometimes they may be a second or 2 too short because you're trying to judge for yourself that point where you can't see the cross. We hope you found this practical advice useful. For expert technical support, please contact the Philip Harris Technical Support Team on techsupport@philipharris.co.uk or visit our blog at philipharris.co.uk/blog.